For r equals 6 sine theta, this polar equation has both the variable theta and r. To graph this equation, we will first plot a few points. When theta equals 0, r is 6 times sine 0 or 0. When theta equals pi over 6, r is 6 times sine of pi over 6, but sine of pi over 6 is 1/2, so this is 3. When theta equals pi over 4, we have 6 times sine of pi over 4, but sine of pi over 4 is root 2 over 2, so this is 3 root 2. When theta equals pi over 3, r is 6 times sine of pi over 3, which is 6 times root 3 over 2, or 3 root 3. And when theta equals pi over 2, r is 6 times sine of pi over 2, but sine of pi over 2 is 1. We choose these inputs because this is a trigonometric function. We would not want to use 1, 2, 3 because evaluating this function at theta equals 1, 2, 3 would not give us nice numbers. We then move on around the unit circle. These are the angles that are around the unit circle. 3 pi over 4. 6 times sine of 3 pi over 4 is 6 times sine of 3 pi over 4 is root 2 over 2. So this is 3 root 2. And then pi. 6 times sine of pi is 0. We observe that r starts at 0, go to 3, increases to 3 root 2, 3 root 3 to 6, and then back to 3 root 2. So there is a symmetry here. It looks like r goes back to 0, the distance of 0, when theta equals pi. We can evaluate a few more points, but we see that since r go back to 0, maybe these are all we need. We set up the x and y coordinate system, but keep in mind that when we plot these points, we would need to use the polar coordinate system. When theta is 0, r is 0, so the point is r equals 0, theta equals 0, which is the pole at the point 0, 0. When theta equals pi over 6, r equals 3, the polar representation is r equals 3, theta equals pi over 6. So we will stay on the ray pi over 6 and go out 3 units. 1, 2, 3, and stay on the ray pi over 6. This point is 3, pi over 6. When theta equals pi over 4, r is 3 root 2, so the polar coordinate is 3 root 2, pi over 4. We stays on the ray pi over 4 and go out 3 root 2. The square root of 2 times 3 is approximately 4.2. The square root of 2 is about 1.4. 1.4 times 3 is about 4.2. So we stay in the ray that is between 0 and pi over 2 and go out about 4.2 units. When theta equals pi over 3, the point is 3 root 3, pi over 3. And again, this time we stay on the ray pi over 3 and we go out a distance of 3 root 3. The square root of 3 is about 1.7. So 3 times 1.7 is approximately 5.1 or 5.2. Again, stay on the ray pi over 3 and go out about 5.2 distance. When theta equals pi over 2, we would go on the ray pi over 2, which is the positive vertical axis, and we would go out 6 units from the origin. 1, 2, 3, 4, 5, 6. And then it looks from the table, it looks that these are going to be symmetric about the points that we just drew. If we are bold enough to connect these points to form a smooth curve, we see that this is half of the circle. By symmetry, we draw the other half of the circle to form one complete circle. So r equals 6 sine theta is a circle in rectangular coordinate system. This circle had the center at x equals 0 and y equals 3 because the diameter is 6. To see that this is the circle center at 0, 3 with the radius of 3, we convert it into rectangular coordinate system. We start with r equals 6 sine theta. Then we multiply r to both sides of the equation. The left-hand side is now r squared. The right-hand side is 6r sine theta. R squared is x squared plus y squared, and r sine theta is y. We then complete the square, move everything to the left-hand side. This is x squared plus y squared minus 6y equals 0. This is x squared plus y squared minus 6y, and to complete the square, we would need to add 9 to both sides of the equation. The left-hand side is now x squared plus y minus 3, the whole quantity squared, equals the right-hand side is 3 squared. This is the equation of the circle center at x equals 0, y equals 3 with the radius of 3.